Before I get into today's forecast, I want to show you something I don't think enough people have actually connected yet. 2.5 weeks ago, a 4th of July weekend severe weather outbreak killed 8 people and injured 18 more across the Midwest, Northeast, and South. This past Saturday, the Storm Prediction Center put an enhanced risk over the Northeast and Mid-Atlantic, and a tornado touched down in Pennsylvania hours after Philadelphia had been under an air quality alert for wildfire smoke that same morning. Monday, that exact same enhanced risk category got issued again, this time for the upper Midwest and Great Lakes. And today, Tuesday, it's happening a third time in 5 days, now sliding across the Ohio Valley and into the Mid-Atlantic and Northeast. Add in a tropical storm currently churning in the Gulf, a flash flood threat that's been building in the southeast for going on 4 straight days, and a heat dome that's about to expand over a huge chunk of the country by this weekend, and you've got what I can only describe as a genuinely concerning pattern, not a string of unrelated bad luck. I want to spend this whole video walking you through exactly what's driving it, day by day, because once you understand the pattern itself, the individual days actually make a lot more sense. It's Tuesday, July the 21st, 2026. Let's get into it. Here's the big picture mechanism first, because it explains almost everything else in this video. For more than a week now, an upper level trough, think of it as a deep dip in the jet stream, has been essentially parked over the eastern half of the country. Instead of one weather system moving through and clearing out, this trough keeps spawning individual disturbances, shortwaves, that rotate through it one after another, almost like cars passing through the same toll booth. Each shortwave drags its own batch of thunderstorms along the boundary, separating hot, humid air to the south from cooler air pushing down from Canada. And because the boundary keeps getting fed by the same reservoir of heat and moisture, the threat just reloads in a new spot a little farther east or south than the day before, instead of the pattern actually breaking down. At the same time, out west, a ridge of high pressure has been building over the interior west and the high plains, and that ridge is about to get reinforced by troughs digging in on both sides of it, one out in the northeastern Pacific and one over the eastern U.S. When a ridge gets boxed in like that, it tends to lock in place rather than slide through, which is exactly why we're not talking about a single bad day here. We're talking about a pattern that's already produced a week and a half of consequences and is showing every sign of continuing. So let's start with today, because it's the most immediate piece of this. The Storm Prediction Center has an enhanced risk, level 3 out of 5 on their 5-level scale, up for a corridor running from the Ohio Valley into the Mid-Atlantic and parts of the Northeast. The core of that risk covers southern Indiana, northeastern Kentucky, southern and eastern Ohio, all of West Virginia, northern Virginia, Maryland, and Pennsylvania, with the broader risk area fanning out to the Mid-Atlantic coast and up into western and central New York. Let's actually talk about why, because I want to get into some of the mechanics here rather than just handing you a map. An upper-level trough is staying put over the eastern U.S. today, and a surface low is tracking from southern Ontario into Quebec, dragging a cold front southeast behind it. Ahead of that front, you get what's called prefrontal troughing, essentially a second zone where air is converging and rising even before the actual front arrives, and that stretches from western and central New York down into the mid-Atlantic. Surface dew points are running into the mid-60s to low 70s today, and that's enough low-level moisture to build what meteorologists call mu Kappa, most unstable convective available potential energy, into a genuinely loaded state by this afternoon. I know that's a mouthful, so here's the plain language version. CAPE is basically the fuel tank for a thunderstorm updraft. The more of it you have stacked up in the atmosphere, the more violently that updraft can accelerate once a storm actually gets going. Kind of like how much more explosively a fire burns the more dry kindling you pile onto it first. But here's the thing about days like today. All that fuel doesn't do anything on its own if there's a lid sitting on top of it. That lid is called a cap, a layer of warmer air sitting a few thousand feet up that acts almost like a glass ceiling, keeping storms from actually breaking through and going vertical during the hottest part of the morning and early afternoon, even with plenty of instability sitting right below it. The cap is actually useful in a weird way because it lets that fuel tank keep filling instead of leaking out through a bunch of weak, disorganized storms all morning. The risk is what happens once something finally breaks that cap. Usually the arrival of the front itself, or a strong enough pocket of lift riding in on the upper level disturbance. Once that lid gets punctured, all that stored up energy can release at once, and that's part of why today's storms are expected to hold off until afternoon and then ramp up quickly rather than trickling in all day. On top of the instability, today's winds aloft are unusually strong for late July. A few thousand feet up, we're talking 35, give it a 58 mile-an-hour winds, and higher up, around 18,000 feet, even stronger, in the 46 to 69 mile-an-hour range. Stack strong winds like that on top of a moist, unstable lower atmosphere, and you get deep layer wind shear. which is the ingredient that actually organizes a thunderstorm instead of letting it just rain itself out in place. Shear tilts the updraft, keeps the storm's own rain-cooled downdraft from choking it off, and in the right spots, gets the whole thing rotating. Forecast soundings today genuinely support supercell wind profiles, meaning the atmosphere has what it takes to produce isolated rotating storms, not just a generic line of showers. That actually brings up the second technical term I want to make sure you understand today, QLCS, which stands for Quasi-Linear Convective System. Most people just call this a squall line or a bowing segment, and it's basically a long, organized line of storms moving as a single unit rather than a scattering of individual cells. QLCS-type storms are the main reason damaging straight-line wind is expected to be today's #1 hazard. When a line like that bows out in the middle, it can produce a swath of wind damage stretching for dozens of miles. And every so often, a quick, short-lived tornado can spin up right along one of the kinks in that bowing line, sometimes with very little warning time. Separately, embedded supercells, individual rotating storms riding along inside a broader cluster rather than standing alone, are also expected today, and those are your better source for larger hail in any longer-lived tornado. The highest confidence for those embedded supercells sits closest to where the surface low and front actually cross paths, roughly from western New York into eastern Pennsylvania,